Hi, Chris here for Tech and welcome to the channel. Well, today it's all about understanding buzzers and add sounds to our projects. So let's get started now. So let's try to understand how buzzers works. First, let's crack it open and we will use a passive buzzer as it is the simplest with the least of components. We have an outside case, the piezo, a PCB and 2 pins. As for the active buzzer, you can pause here if you wish to see what is inside. There is just an added driver actually, but he makes all the difference. Now, about that Piezotype buzzer. It is a piezoelectric element which consists of a central ceramic disc surrounded by a metal one, often made out of bronze. This metal plate is also known as a vibrating disc or vibrating plate. Both discs are held together with adhesives, with attached to each other a wire for electrical conduction purposes. You can see here a positive and a negative. When the current is applied to the buzzer, it causes the ceramic disc to contract or expand. In turn, this causes the surrounding disc to vibrate, inducing a mechanical strain. This causes the material to develop an electric field and vice versa. These piezoelectric plates are in turn connected to the positive and negative terminal as we saw earlier. When an alternative voltage is applied, the piezoceramic element expands and contracts diametrically. This characteristic of piezoelectric material is utilized to make the ceramic plate vibrate rapidly, which generates some waves. That is the sound we hear. And by changing the frequency of the buzzer, the speed of the vibration changes as well. This, in turn, modifies the pitch of the resulting sound. The piezoelectric material exhibits a specific phenomenon known as piezoelectric effect, as well as a reverse piezoelectric effect. For those with a headphone, this is a warning for the volume, as here are a few applications that make uses of the buzzer. We have the timer, the alarm clock, the washing machine, and also the doorbell. Of course, there is many more too. Now, for the details and features for buzzers. They usually operate with a voltage in between 4 to 8 volt DC. We can input a maximum current of up to 30 milliamps. The sound emitted from the buzzer is of a continuous beep. The buzzer's frequency used is in the range of 2300 Hz. Finally, the fact that they do come in a very small seal package makes them friendly for breadboards and many projects. The word piezoelectric is deriving from the Greek piezon, which means to squeeze or to press. Piezoelectric buzzers are very small yet efficient components, which will add beeping or buzzing sounds like feature to your project. Being very small and compact, 2-pin structured by themselves, they can be easily used on breadboards and act as an indicator, which makes them widely used components as audio signaling device, which can be integrated in electronics. Now, enough of the theory, let's dive into the practice. We are simply going to use this active buzzer by connecting the negative to the ground, the positive hand to the Arduino pin 8, like so. The wiring circuit is done, as we can see here. It's as simple as that. Hopefully. The only things to do is to jump right into the code now. Well, all we need is those two integers here. One is to declare where the buzzer is attached, here to pin 8, and the other one is to set the delay at 500 milliseconds. Then in the whole setup we have the serial begin just for debugging, and we declare our pin mode, which is the bus pin here. We set it as an output. Then to finish, in the void loop we have a digital write for the bus pin. We set it to high or we turn it on. We apply the delay, then till with the digital write, we set the bus pin to low or we turn it off, and we put the delay. This being inside the void loop, it will continue on and on and on and on until we stop it by unplugging the Arduino or our project run out of power. Knowing that, it is only fair to remind the viewer using headphones to lower down the volume before we send this to the Arduino for the reason I just explained. And you see, just like that, we added sound to our project. But this is a little bit annoying, so let's unplug this. Another thing to note is if you cut this and paste it in the void setup like so, then when you send this to the Arduino, you will have only one beep. Ta-da! Alright, now we can go to the better stuff. But first, just look at this video if you don't understand this sketch. Otherwise, more details also, simply look at this video too. Or you can continue and try to figure out by yourself. Right, we have our buzzer on pin 8 and we have those that we will apply, all the messages. Okay, we have created the user choice. Then in the one setup we have the serial begin just for debugging, and we declare our pin mode, which is the bus pin here. We set it as an output. Then to finish, in the void loop we have serial.println and we print the message. In the while loop we have the serial.available, which is equal to 0. Then after that, we have the user choice with the serial, and here it's a parsing. Then we have our first if statement. If the user choice is equal or above 1000, then we print the message 2. Then the user choice, we add the message 5. Then we start the buzzer high. We put a delay, and you can see now we have low. We put a delay. As you can see, it's all the series for many beeps. Here, high and low. Then once this is done, we have the second if statement with the user choice, which is in between 500 to 999. Oh, it's not 999, okay? Anyway, so we print the message 2, and then we have our buzzer low, high, low, high. And this time we will print the message, then we will put the user choice and we print the message 3. The next if statement is the user choice. If it's bigger than 0 and smaller than 500, then we have only 1 beep. And you notice here I start by putting the buzzer pin to low, because since this is in the loop we do not know. So we start by low, then we have a high and a low, of course. Then message. Once this is done, the last if statement with the user choice, if it's equal 0, you remember why we do that, we print the serial message and we put the digital write here high only. Then we print the user choice here, then the message 4. So as a reminder, let's go up and see what the message is about, which is the warning here, the circuit is offline. Alright, so now we see all the sketch here. We can send this to the Arduino and start to check how this works by bringing up the serial monitor. But before I start testing the sketch, be aware that when press enter there will be a permanent tone. So once more, for those who have a headphone, well, you know what to do. Okay, so we start with the 0. I will, however, try to stop as fast as I can. I try to input a 1 in order to stop the long beep as fast as possible. And after that, of course, we will test to see if the sketch works. So now I have a question for you. Are you ready? Go! Okay, you can see there is a sound. Next, I put a 1. Yes, it works. You saw? Only 1 beep. So far, we saw that the 0 works, above 1 works. What about less than 500? Let's say maybe 200, like so. Yep, that works as well. And to verify that the range works, we verify just under 500 and you can count 1 beep. That works as well. Now let's try 500. We have 5 beeps. Yep. Now we can do above 1000 and see how it works. For this one we expect 5 beeps and 1 long. So get ready. Yep, that's about it. Better to stop it because this is quite annoying, and it gives me the opportunity to give you your assignment for next week, where for above 1000 I want the red LED, in between 500 to below 1000 I want the orange LED, for 1 to 499 I want the green LED, and again red LED blinking when it's 0. Thank you guys. That is it for today. Thank you for watching the video. And just to let you know, I started the Patreon where if you want, you can support me. And again, if you enjoy it, you know what to do. You can do your YouTube things, like if you want to. Subscribe, you may as well. Or you can also press the bell icon if you want to be notified every time I post a new video. However, if you do not like this video, simply leave a comment down below and tell me why it's so. I will try to improve for you guys. Stay safe and bye now!